Welcome to the classroom. Today we're learning about measuring strike and dip. So in order to measure strike and dip, we can use our compass, or we can use an app called the Clino app, and there are many other apps out there available to measure strike and dip. Why do we measure strike and dip? Well, we want to understand the orientation of different planes in space. Different structural geological features can be represented by planes, like joints or bedding planes, but also foliation planes, cleavage planes, limbs of a fold. All these things, we can go out into the field and measure their orientation. And we say we measure their strike relative to north and their dip relative to the horizontal line. The planes in nature are not always that smooth. That's why I built these. So we have a nice smooth surface to put the compass on, and you can get familiar with measuring strike and dip. So let's go and have a closer look at how we measure strike and dip. All right, so before we get measuring strikes and dips on actual planes and the planes I've made up, we need to understand our compass. So our compass has a whole pile of tools. Here I've got the Suunto MC-2. It's used for navigation. We can use it for mapping. It has a scale on the outside edge. We can get angles measured and everything for plotting those on our map. Has magnifying glass. It's used in a lot of different applications, but definitely in structural geology and mapping. All right, so we have this outer dial of numbers here, and you can see north, east, south, and west markings. So this is what we will use to measure our strike. And it goes from 0 to 360 degrees relative to north. You can see a red arrow here, and it's always pointing to magnetic north. I've already set the declination. So on the back side, there's a tiny screw here, and you can see a second set of numbers on the inside here, which go from 90 to 0 and 0 to 90, some going east and some going west. So you can use that gradation to dial in your declination. So there's a little tiny screw there, and you can turn that, and that will move the double black arrow. It's got two lines on either side, not the arrow that moves with the dip. Okay, we'll get to that in a moment. This black arrow here, and you can see I'm about negative 10.5 degrees here in Peterborough. That's the declination towards the west. Okay, and you want to set that up so that you have reference to the true north. So the magnetic north actually drifts a little bit, and you need to look that up. Every location you go, you look up the declination and you adjust your compass. All right, and that inner gradation that we use for the declination is actually also used for the dip. So there is an arrow pointing down here. You can see that it rotates and is always pointing down. How do we measure our strike? I always use the mirror side of the compass as the direction I want to be navigating in, or in the direction I'm actually taking my strike measurement. And what we want to try to do is rotate this dial. You can see these two red lines that form an arrow. Okay, that is pointing to the north with an offset for the declination. And we want to rotate that around so the magnetic north arrow lies inside the bed, we call it, inside those two arrows. So we just rotate it around until it is in the bed. The magnetic arrow is outlined by the red arrow that points to our dial. And then we can take the reading of the measurement up here at our indicator. There's a little white line there. That's our indicator of our strike orientation. Now the compass is held flat here. We want to do that on our plane as well. So it takes a bit of practice to get that right. But we always want to be pointing towards the mirror and reading the number off that direction. Now for the dip, we can either place the east at the upper indicator or the west. It depends on which way you want to measure your dip and what's most comfortable for you. But that just puts the gradation for the dip so that it is perfectly 90 degrees to the long edge of the compass, and then we can put that long edge down on our plane, and if it's dipping, then we'll get a good measurement off that inner dial that goes from 90 to 0 to 90 again on the other side. So let's bring a plane in and let's take some measurements. All right, so here we have a nice wooden plane. It's smooth. I've tested it already. The screws I've used are not magnetic and they won't interfere with our compass readings. Now, I always want to dial in the north, all right, up to my indicator line. I always want to start in the same position so that I don't forget the steps. So I want to check the plane with my right hand. So I put my right hand on the plane and my thumb points in that direction. Now, given the sun's position, my general idea of where we are, north is basically behind me and south is in front of me. So I should always think in my mind, what is the reading that I'm going to try to get? And it should be around 180 degrees for the strike because my thumb is pointing in a southerly direction. I don't know if it's exactly 180 or not. That's why we're going to use the compass. But I want to have an idea of my spatial awareness before I take the measurement. So if I go and I want to hold the compass, keep the compass flat, but also then you want to line up, on the plane, you can see the horizontal line here. So the strike is a horizontal line on that surface. Imagine we filled this up with water. The water would lie perfectly in a horizontal line. And that's the line we want to measure. That is the strike. So we just take our compass. Now we see the magnetic arrows pointing in this direction and the dial indicator is over here. So I need to rotate my dial so the magnetic indicator is lying in the bed of the dial red line. So I just line that up. You might need to adjust it a little bit. Okay, and you can see if I am not perfectly level, the magnetic arrow wobbles a little bit. So that's pretty good. And once you've got it lying in the bed, the dial doesn't change. The number up here, you can bring it a little bit closer and you can see we're at 150 degrees. All right, so we're pointing in a southerly direction. It's not exactly 180, it's actually 150. That is the strike direction. And it's in the direction my thumb was pointing, so it makes sense. Now what we want to do is take our compass and rotate it around to the east-west direction. And now we want to make sure that's going down in the direction that water would run down our plane, at the steepest direction. You can wobble it around a little bit and make sure that you have the steepest angle that you can get. And now we're actually looking at this little black arrow that's pointing down at about 40 degrees. All right, so that is the dip direction. So our strike was 150, our dip is 40 degrees. And now we can use that measurement to plot our layer, and we know our location. So now we have a spatial awareness of where this plane exists in space and what rock type it represents. And we can actually go out in the field and get all these different locations. And that's exactly what we're going to do in our first lab exercise for EGO 3002. I've got a bunch of these set up in the field and we can go and take some measurements. I've made up a map for you. We're going to go to these locations on the map and each one will have a rock unit labeled on the platform here. We can take our structural geological measurements and they'll be labeled what we have there. And we can fill in our map, and this is simulating a real world exercise. I want you to practice before we actually go into the field because it's a lot more difficult in the field. The planes are not necessarily perfectly smooth and their locations, we actually have to go and find them, paste them out, use satellite imagery or GPS and plot them. So we'll also practice using the Clino app. I'll link to a previous video on the Clino app in the description below and using that, but we'll practice both using the compass and using the Clino app, and we'll compare our measurements while we do our mapping exercise. So thanks for watching. I hope this helps you understand how to measure, strike, and dip